Hi all, welcome back to Neo Home Tuition. It's me Nasira Anish. ഇന്ന് 3rd സ്റ്റാൻഡേർഡ് ഫിസിക്സിലെ ഫസ്റ്റ് ചാപ്റ്റർ ഇലക്ട്രിക് ലൈൻസ് ആൻഡ് ചാപ്റ്ററിലെ വളരെ മനോഹരമായ രണ്ട് കൺസെപ്റ്റുകളുമായിട്ടാണ് മിസ് വന്നിരിക്കുന്നത്. എന്റെ എല്ലാ കൂട്ടുകാർക്കും ഇന്നത്തെ ഫിസിക്സ് ക്ലാസ്സിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. അതോടൊപ്പം തന്നെ ഫസ്റ്റ് we have to check what will be today's GK question. അല്ലേ? ഇന്നത്തെ GK question നിങ്ങൾക്കായി ഇവിടെ റെഡി ആയിട്ടുണ്ട്. Before starting our session, let us check that GK question. What it is? Which state government has launched Nodi Bandhan scheme? Which state government has launched Nodi Bandhan scheme? Options are given there. West Bengal, Kerala, Bihar and Odisha. You have to choose the correct option. അറിയില്ലാത്തവർക്കായിട്ട് നമുക്ക് ഈ സെഷന്റെ ലാസ്റ്റ് ഇതിന്റെ ആൻസർ ഡിസ്കസ് ചെയ്യാം. Okay, if you are ready, let us move to our session or our concept, that is electric lines and charges. So before going to this chapter in detail, we should have the concept or we should have the concept that we have to discuss here or in this class. So let us check which are they. First of all, we have to come across with electric field lines. Do you know what it is? Yes, electric field lines നെ കുറിച്ചും അതിന്റെ properties നെ കുറിച്ചും നമ്മൾക്ക് പഠിക്കണം. After that, we have to come across with electric flux. Then we have to form an important law relating electric field lines and flux. നിങ്ങൾക്ക് ഏകദേശം ഒരു ഐഡിയ കിട്ടിയെങ്കിൽ നമ്മൾക്ക് നമ്മളുടെ ഫസ്റ്റ് ടോപ്പിക്കിലേക്ക് പോകാം. Let us move to that topic, that is electric field lines. What is electric field lines? Lower class മുതൽ തന്നെ നമ്മൾ പഠിക്കുന്ന ഒരു കൺസെപ്റ്റ് ആണ് electric field lines. If so, how we can define it or what it is? Yes, field lines are imaginary lines drawn in such a way that tangent at any point will give the direction at that point. എന്താണ് പറഞ്ഞിരിക്കുന്നത്? Field lines are imaginary lines ആണ്. If we are drawing tangent at any point will give the direction of field lines at that point. അപ്പോൾ field lines ന്റെ definition നമ്മൾ ഫോം ചെയ്തു. അതിൽ നിന്നും രണ്ട് പോയിന്റുകൾ നമ്മൾക്ക് ക്ലിയർ ആയി തന്നെ മനസ്സിലായി. ഒന്ന് field lines imaginary lines ആണെന്നും രണ്ടാമത്തേതായി tangent ഏതെങ്കിലും ഒരു പോയിന്റിൽ നാം വരക്കുന്ന tangent അത് എന്ത് നൽകുന്നു? ആ പോയിന്റില് ഇലക്ട്രിക് ഫീൽഡ് ലൈൻസിന്റെ ഡയറക്ഷൻ നൽകുന്നതായും നമ്മൾക്ക് മനസ്സിലാക്കി. Then പല കേസിലും നമുക്ക് ഇലക്ട്രിക് ഫീൽഡ് ലൈൻസ് വരക്കേണ്ടതായി വരാറുണ്ട് അല്ലേ? If so, how we can draw this electric field lines? അതിനു വേണ്ടി ഒരു പ്രത്യേക കണ്ടീഷൻസ് ഒക്കെ ഉണ്ട്. ആ കണ്ടീഷൻസ് മനസ്സിലാക്കിയാൽ it is very easy. If so, let us check which are the properties of these electric field lines. What's the first point? അതെ, ഇലക്ട്രിക് ഫീൽഡ് ലൈൻസ് സ്റ്റാർട്ട് ചെയ്യുന്നത് പോസിറ്റീവ് ചാർജിൽ നിന്നും എൻഡ് ചെയ്യുന്നത് നെഗറ്റീവ് ചാർജിലുമാണ്. സോ how we can draw electric field lines? എപ്പോഴും സ്റ്റാർട്ട് ചെയ്യുന്നത് പോസിറ്റീവ് ചാർജിൽ നിന്നും എൻഡ് ചെയ്യുന്നത് നെഗറ്റീവ് ചാർജിലുമാണ്. Then they do not form any closed loop. അവ എന്ത് ചെയ്യുന്നില്ല? ക്ലോസ്ഡ് ലൂപ്പ് ഫോം ചെയ്യുന്നില്ല. Then electric field lines never intersect each other. What it mean? Electric field lines ഒരിക്കലും intersect ചെയ്യുന്നില്ല. If they intersect each other, what will happen? നമ്മൾ പറഞ്ഞല്ലേ, ഏതെങ്കിലും ഒരു പോയിന്റിൽ ടാൻജന്റ് വരച്ചാൽ that will gives the direction of electric field lines at that point. If so, they intersect each other. What will happen there? Yes, they will give two direction of field lines. Is it possible? No, it is not possible. That's why electric field lines never intersect each other. Then next, what it is? Whenever we are drawing these field lines, if they are crowded, what it means? Yes, field lines are strong. If they are not crowded, the field line is not strong or they are very weak. Okay, if so, what about the direction? So every time field lines are normal to the surface of charged body. Electric field lines are normal to the surface of charged body. Then we can say that electric field lines can be taken to be continuous curves without any break. These are the properties of electric field lines. Please once more go through all these points. If you understand this, let us try to draw electric field lines in different cases. Get ready with a paper and pen. Okay. So what will be the field lines in the case of a single positive charge? Yes. We know that field lines start from positive charge. So the electric field lines are like it is given here. So now we have the idea of electric lines of a single positive charge. If so, what about a single negative charge? Yes, it is point towards negative charge. Why? As we know, in the case of electric field lines, it ends at negative charge. If so, by comparing these two field lines, what you conclude? We can say that the case of single positive charge, field lines are radially outward, while those of a single negative charge are radially inward. Okay, Leah concept? If so, what about a system of two positive charge? Yes, from this picture, it is very clear. അല്ലേ നിങ്ങൾക്ക് എന്താണ് അതിൽ നിന്ന് മനസ്സിലാക്കിയത് അപ്പൊ എങ്ങനെയാണ് അവിടെ ബിഹേവ് ചെയ്യുന്നത് if we are bringing two positive charges we know they repel each other isn't it so we can say that in the case of for a system of two positive charge describe the mutual repulsion between them that is why the field line picture is as like given here. If so, what about in the case of two negative charge? As before we know, two negative charge. In the case of two negative charge also, there will be mutual repulsion between them. If so, if we consider a single positive charge and negative charge together, how we can call that system? Do you remember? Yes, that is an electric dipole. If so, how we can draw electric field lines of an electric dipole? Yes, the case of electric field lines of an electric dipole, we can say that which will give the mutual attraction between them, isn't it? Which will give mutual attraction between them. So, let us draw all these pictures in a single sheet. Let us compare all these field lines. Please do it. In the first picture, that is in the case of positive charge, it is radially outward. In the case of negative charge, it is radially inward. In the case of a system of two positive charge, it represents repulsion. But in the case of an electric dipole, it represents mutual attraction between them. So now we have the concept of electric field lines. No doubt. If so, how we can represent the number of total, how we can represent the total number of field lines through a system? Yes, that is represented by the term electric flux. What do you mean by electric flux? Yes, it is defined as the measure of total number of electric field lines passing normally through a given surface. The picture is given there. This picture depicts the electric flux. What do you understand by the term electric flux? Yes, it is the total, it is a measure of total number of field lines passing normally through the given surface. So, how we can represent this definition in mathematical form? Yes, we can represent it as flux phi is equal to E delta S cos theta, where delta S is the area vector. So, we can represent this equation as delta phi, electric flux delta phi is equal to E dot delta S. But in this second picture, what do you understand? If the field lines are normal to the surface, or if the surface is perpendicular to the field lines, at that time what about theta? We know theta is equal to 0. Let field lines and area vector are parallel to each other. That is why theta is equal to 0 and cos theta is equal to 1. Then this equation becomes delta phi is equal to E delta S. Then by using the concept of electric field lines and electric flux, there will be an important law known as Gauss law. Next we have to define or state Gauss law. So we understood that Gauss law describes the relationship between electric charge and electric flux. So how we can state? It states that the total electric flux over any closed surface enclosing an volume in vacuum is 1 by epsilon 0 times the total charge enclosed by the surface. Once more, it states that the total flux over any closed surface enclosing an volume in vacuum is 1 by epsilon 0 times the total charge enclosed by that surface. That is why we can write that equation as phi is equal to 1 by epsilon 0 times Q, that is total charge. Or we know the equation of phi. General equation of phi as surface integral of E dot dA, that is equal to 1 by epsilon 0 times the total charge, that is Q. That's about Gauss law. So, in this session, we discussed electric field lines, properties of electric field lines. Then, we draw electric field lines of different cases, that is positive charge, negative charge, and a system of two positive charge and a system of one positive charge and a negative charge. I think all these points are very much clear with you. So before winding up this session, we have to answer that GK question. Do you know the answer of that? What it is? Yes, that is West Bengal. The answer is West Bengal. If so, let us wind up our session. That's all. Thank you.